What's going on, Accelerated Algebra? This is lesson 2.8. I forgot to write that up here. This is 2.8, two variable inequalities. So 2.8, two variable inequalities, 5 boxes. I know some of you guys are on the retreat, so here's a little lesson for you. Okay, first thing we gotta understand is let's talk about a linear inequality. Here's an example of a linear inequality. It's over here in this little blue cloud. The only difference between a linear inequality and a linear equation is the inequality sign right there. So notice what it does to the graph over here on the right hand side. This is the graph of this linear inequality. So notice that this little dashed line here creates what's known as a boundary line. And what it does, it cuts the plane in half into two parts, right? You'll notice that one side is darker than the other. That's because all the solutions to the inequality lie in the shaded region. And you'll notice that the graph is dashed here because my inequality is strictly a greater than. So how do I know that my solutions are over here in this area? Well, you can easily take a test point, and I always recommend taking the test point 0, 0. And here's why. If this is the point 0, 0, I have an x that is 0 and a y that's a 0. If I plug them back over here, look what I get. 0 is greater than negative 2 times 0 plus 2. 0 is greater than 2. Is this a true statement or a false statement? Well, this would be a false statement, right? So it's not the case that 0, 0 lies in the solution region, so therefore it must be the other one, and sometimes you'll see me shade things that look like this. Okay, this is a linear inequality. Let me give you another example down here. So here's the box number 2. Notice this one is a less than inequality, and notice that my boundary line is a solid line here. The reason is because I have a less than or an equal to. Okay, let's take the test point 0, 0 and see if this makes this inequality true. Is 0 less than or equal to 2/3 x plus 1? Well, is 0 less than or equal to 1? Yes, that's a true statement. So it must be the case that 0, 0 lies in the region. This is my region that makes my inequality true. So you can always test 0, 0, and you're looking for true statements in this case. So in this case, I would shade down here to the left, okay? Let's go back to this one. Let's try this one here. Let's graph a linear inequality together. So imagine for just a moment that this is the line, this is an equation, y equals negative 2x plus 1. Well, we would just do the exact same thing that we always would do. We would go up to 1, we would apply the slope, which would be down to 1, 2 over 1, and we would draw a line. In this case, I would make sure that my line is solid because I have a greater than or equal to. So I'd have a solid line that looks like this. Of course, you guys would use a straight edge. I don't have one right now. And then I would test the point 0, 0. So let's see here. Is 0 greater than or equal to negative 2 times 0 plus 1? So is 0 bigger than or equal to 1? That's definitely false. 0 is not bigger than 1. So therefore, it's not the case that 0, 0 lies in the shaded region. So therefore, I would shade all this information over here. We can verify this result by actually graphing in fluid math what I have, and check it out. This is exactly the same thing that we just came up with and we graphed ourselves, right? If I make zoom in a little bit bigger, look, 0, 0 is not in the solution region. Okay, moving right along here. What about an absolute value inequality? How do we graph one of these? Well, since we're dealing with absolute value, you should always know that your graph is going to be some kind of a V, right? Maybe it's upside down, maybe it's skinny, could be stretched or reflected, some kind of a V. So let's start by isolating the y. So I'd get negative y is less than the absolute value of x plus 2, and then I would subtract 1 here. And then I don't want negative y, I actually want y. So if I multiply the entire thing by negative 1, we get this. Y is now greater than, don't forget to reverse the inequality sign, negative absolute value of x plus 2, and then a plus 1. All right, so this is a useful form for us because the vertex now is at the point negative 2, comma 1. So go over to graph and put negative 2, comma 1. Okay, there's my vertex right there. And because the graph is a negative on the outside, sorry, because my negative is on the outside of my function here, I want a reflection over it. So this is going to be down 1 and over 1. So I'm going to have something that looks like this, okay? But it says strictly greater than, so that means I would use a dashed line here, and so I have to erase the whole thing, it goes away. So I'd have to use the dashed line here, looks like this, and then like this, okay? and I want things that are greater than or above that. So I can still test 0, 0 to see if it's in that region. The same trick applies, right? So test 0, 0 on the original function here. So, or it doesn't matter. You can use it on any one you want. So here, if I go 0 greater than or equal to the negative, let's see here, 0 plus 2 is 2, and then plus a 1. Absolute value of 2 is 2. Make that a negative 2. So 0 greater than negative 2 plus 1. So is 0 greater than negative 1? Is that true or false? That is a true statement. So therefore, I would shade everything above this region right here. Okay? To get a better representation of what this would look like, we can use fluid math. So it would be this one here. Notice I have the exact same equation or inequality set up, excuse me. And then if I graph this, look, we get this exact same thing here. Wait, did I put a minus 2? I think this should be plus 2. There we go. Now it's in the right spot. And that's what I had here, right? A plus 2? Yeah, plus 2. There it is. Okay? So this graph represents exactly the same thing that we just figured out. We have our region, we have our boundary line, and it's just in the shape of the absolute value. Okay, one more for you guys here. And this is actually homework problem number 25. And the reason I'm doing this one is because of this little 2 right here. So let me give you a demonstration. So negative y is less than 2x minus 3, and then we would subtract 1. So y would be greater than the negative of 2x minus 3, and then a plus 1. So where's the vertex? Well, here's what I want you guys to be able to realize here. Y is greater than the negative of, you can factor out a 2 inside the absolute value inequality. So you would have an x minus 3 halves and then plus 1. So notice that 2 times x gives you your 2x, and 2 times negative 3 halves, of course, gives you the negative 3. So your vertex then would be at the point 3 halves comma 1. So when I would graph that, I go to 3 halves comma 1, and the 2 still makes your graph a little bit skinnier because you're both multiplying by a factor of 2. So let's take a look at this and what this would look like here. So check it out. I have both these equations set up for you ready to go. Notice that the top one is the exact same thing as the bottom one, except the bottom one has been factored out a 2 inside the absolute value inequality. So when I graph both of these, notice that we get only one graph because they're both the same. Okay, so where did I say that the vertex of this thing would be? It should be at 1 half comma 1, and look, there it is, 1.5 comma 1. Can you guys see that? Moving kind of slow, and there it is right there. And then we would just take our test point at 0, 0, and we would graph. Hope this helps you guys.